Hey everybody, I'm really excited to be here. As Michael mentioned, I used to work at Predabase back in the day. I was, one of the first people that they hired, and so I really enjoyed, kind of like parallelly working in this space for a few years now. So I'm going to set up my talk. Awesome. So in the in the presentation today, I have about 20 minutes with me, and I'm really going to be taking these 20 minutes to really talk about like how we can look at all of the volatility in generative AI today, and then like mitigate a lot of that volatility with technical tools. Before I get started, a little bit about me. As Michael mentioned, I'm the CEO and co-founder of Guardrails AI. My background, I've worked in machine learning for many years now, about 12 years or so now. In the past, like some interesting thing stuff I've done, that really motivates how I look at, building technical tools for improving generative AI reliability is, my work in classical AI and deep learning research and computer vision research. I used to work in self-driving cars for many years, as well as, the years I spent at Predabase. Awesome. So this is if if any of you guys have like really built any applications or used generative AI and LLMs in any of your workflows, you really understand that these are like really powerful models that can solve a lot of problems under the sun. But they're very different from how traditional software works, right? So for traditional software, we're very used to this idea of many nines of reliability. So we'll typically ship software when it's at 99.999x. With Gen AI, the world is a little bit different. We tend to see a lot of like flexibility in how LLMs and generative AI work, but at the same time, that flexibility is mirrored with a lot of volatility, where we can't really guarantee like the same or similar or consistent responses in the way that we can with like traditional software, right? So I've included like some examples here of organizations that are maturing and really now trying to deploy these systems that are built with and powered with generative AI into like real world cases or real world use cases, and then what some of the ramifications of that are. One of my favorite ones was that New York City deployed a chatbot which was built with Microsoft and like powered by some of the Microsoft LLMs, that said that it's okay. The chatbot was supposed to help small business owners, that said that okay, it's okay to like cheat, it's okay to maybe not be very consistent with like health and safety, food standards, etc., right? And then as these chatbots become more and more a part of our lives and the services we interact with daily, another kind of like open question that really calls to the need for reliability and better risk management for a lot of these AI systems is like, who is liable when this New York City Microsoft chatbot, like misleads its citizens, like who's liable and who's on the hook? And there's an ongoing conversation, but a lot of the new kind of like theories around this kind of like really dictate the need for like enhanced reliability measures, right? So in this talk, what I'm really going to do is like look at what are some of the big sources of the causes of that volatility in the Gen AI life cycle, and what we can really be doing to mitigate a lot of those volatility issues. So the most interesting thing here is that volatility isn't a single stage problem. It really runs through the life cycle of Gen AI application building, whether that's development, deployment, or runtime. There's different types of volatility that kind of like cause, different types of like unreliable behaviors, right? And so there's no magic wand per se to really mitigate a lot of these like reliability issues. And what we really have to do is, like look at what the sources of reliability of volatility are, and then patch those types of failures at that stage. So here are some of the ones I'm really going to take a look at is like during development. If you're building with Gen AI applications, a lot of the unreliable behavior might come from, just insufficient model capabilities. No amount of prompt engineering, etc., is ever going to make that problem go away, because that model just does not have that capability, right? If you actually want to test this out, why don't, like my favorite kind of like example to actually take it for a spin is if you ask, your favorite commercial LLM to count the number of words in a sentence, right? And this is something that like may seem very trivial, but it's just outside of the capabilities of what the model have. If you're doing anything with like retrieval augmented generation, then improper or inappropriate context for those applications tends to be a huge cause of, unreliable or volatile behavior. Hallucinations is a top problem with these systems today. And a lot of hallucinations can actually be pointed to, like this issue of like improper context. In the deployment stage, I think there's different types of unreliable behavior that cause this volatility. One of the big ones is, improper application usage. And you see this a lot, and I'm going to dig into this a little bit more. But, your application, because of like the infinite number of inputs that you can send into a chatbot or a text box and the infinite number of outputs you can end up getting back, your application might end up being, used in very different contexts for which you developed it, which might lead to, like unreliable or volatile behavior. Edge cases, another kind of like huge issue with these AI models, and then just fundamental model jitter at runtime. Awesome. And then what I'm going to kind of like talk about throughout this talk is like a fundamental kind of like paradigm of like building with these LLM, building applications with these LLMs that like tackles this source of unreliable behavior at its source, which is, validation and verification. And the idea behind validation and verification is like really straightforward, which is that because there's so much like natural, like stochasticity in these models that, are from all of these different causes. Unlike with traditional software, what we have to do for AI software is explicitly validate and verify every single thing that we do at every one of these stages to measure when that's happening, right? And as long as we can measure the sources of this unreliable behavior, we can really make sure that we're kind of like tackling it and attacking it in the right way. Very pointedly, like there's also other sources of unreliable behavior, such of volatility, such as like data volatility, very, commonly like, distribution shifts or data quality issues, etc. Initialization randomness, like resource constraints or volatility from, just not having enough like compute or infrastructure. Those problems are pretty critical, but they're also not novel to generative AI, whereas like a lot of the other ones that I talked about before are. And so for this talk, I'm only going to focus on, these Gen AI specific volatility issues. Awesome. So, as I mentioned, like the key paradigm with which we're going to attack this volatility is this idea of like validators that very explicitly validate and verify any single assumption that we're making out of our AI system, right? And then what this looks like is that let's say you have an LLM application and the fundamental kind of like way that you build that LLM application is, you have a prompt, that gets sent over to an LM that gets an output, right? And you might end up kind of like doing interesting things to it. Like if you're building like agents, you'll combine like many different of these like cells, which are kind of like these fundamental LLM block into, like chains, etc., or like agentic workflows. You might end up doing a lot of prompt engineering, which all of that would end up going like here into the investment. Or you might, like, so let's say fine tune an LLM, which is, all going to go into like this portion of your application, right? With validation, like the key kind of like switch is to really think about like adding explicit verifiers around your AI application that are, checking your assumptions and checking your unreliable behavior at every single step. So what this might end up looking like will be very different based on what application it is you're building. And is going to be, like, let's say, for example, you're very sensitive to, like private information or PII leakage, or making sure that there's no proprietary information that is being used to answer any question. There's no jailbreak attempts that are ever detected, right? So all of those need to be explicitly verified before you bring in the LLM, which is, adds all of this like unreliable, volatile behavior. And then on the output side, the same thing. Before that, source of unreliability is passed through to the entire application, making sure that you pass that LM output through output validation, which, will check for, are there any hallucinations present? Are there any, like not safe for work or a violent speech or anything that's detected or like sensitive topics, etc. And only once we have enough confidence that, there's none of this like unreliable behavior present in the LM request or response, then we can, like kind of capture that unreliability at the source of the LM. Awesome. So these validators can really be, like very, very versatile. They can be like rules or heuristic systems, such as, like regular expressions, pattern matching, keyword filters, etc. They can also be small, fine-tuned ML models, such as, for classification, factuality detection, topic detection, or named entity recognition. And they can also be secondary LLM calls, also commonly known as, like LLM as a judge, which really kind of like uses another LLM, maybe smaller, fine-tuned for that specific task, to kind of like check for toxicity, rate the tone of voice, verify coherence. So all of these like really complex problems that are harder for, like more traditional ML models. And then most commonly, like these validators end up being, a combination of these three types of approaches. Here's also where, like the work that we do at Guardrails really comes in. At Guardrails, our core is to really build out a lot of these validators. So we're an open source company that manages, popular open source project called Guardrails AI. And what we've really built out is this community hub of validators for a lot of different types of use cases, like these seven or so, or eight or so use cases. Yeah, I think seven use cases here, these like eight risk categories. So we have like all of these like validators that, we've built or the community has built that really like takes a look at all of these sources of unreliable behavior and, captures it at that source. Awesome. With that setup out of the way, let's take a look at, how we start attacking all of these sources of unreliability. So the first one is insufficient model capabilities. And then my key suggestion for tackling, volatility from insufficient model capabilities is to be very educated, and very intentional about like what you're expecting out of the LLM. So, my top suggestion here is going to be like, be very careful about like which benchmarks to take a look at. So here I've, like added this snippet from, the Scale AI leaderboard on instruction following, which, basically compares like the top LLMs on like what their top three criteria and their bottom three criteria per model is. And that gives you an idea of like this assumption that I'm making out of my LLM to help me with, is this something that is an innate capability that this LLM is even supposed to be good at, right? So here you can actually see that like claim factuality, or, like in other words, like something that, you can use to verify hallucinations, right? Is actually the bottom three criteria of both OpenAI O1 preview and Claude 3.5 Sonnet, which is fascinating, right? Claim factuality, which is like our all response statements that are generated by either the top Claude or the top OpenAI model, actually factually true. And then surprisingly, that is not the case. So if you are simply relying on, just these OpenAI out of the box models, et cetera, to get like very factual, not hallucinated information, that's just not, that's just an insufficient model capability issue, right? So this kind of like gives you the suggestion where if you're building an AI application, then you should really kind of like think through, okay, how can I update, the model or add like other kind of like secondary sources of verification, etc., to kind of make sure that, my claim factuality is actually truthful so that you can reduce hallucinations. Um, Oops, sorry. This is, sorry, just a second. I think there's something wrong with my animation. What I wanted to kind of like showcase here is also that, yeah, I think there's something messed up with my animation, but this is like one of the things where, also having access to, our open source hub kind of like presents you all of these validators that, you can use on the open source hub, to kind of make sure that, you really you can verify any claim very explicitly. So we have like a bunch of factuality validators that we have built that have been contributed to us by other, like state of the art, like organizations that are only looking at factuality. And that can make sure that you can add these validators to your application and make sure that you at each step explicitly verify, is my system like truthful or not, using these validators. Sorry about the missing animation, folks. The second is improper context. So the core idea kind of behind improper context is, this idea where because like these systems are kind of like, only typically based on like similarity matching, that can that can often be very error prone, in terms of um, uh, kind of like leading you to kind of like missing context or bad retrieval. So I have this example here where let's say you have like a Slack chatbot that you've built, right, where people can ask questions about like how different, organizations are performing. And then some user comes in with just the query, how is the project going? No extra context, right? So, and there's a bunch of issues that you can kind of like already spot here. The first is like, what does it mean in terms of how the project is going, like which project, what's the success criteria that we're really talking about here, what's the timeline, right? And then also there's issues with like bad retrieval, so that you end up maybe retrieving the wrong documents that maybe have like outdated information or only partial context that doesn't, tell the whole story. So because of like, this incomplete information present in the context, you might end up getting like very, very, very different responses for the exact same question, which is, like, you might end up with a progress report on the completely wrong project because you never specified what the project was. You might end up with like some hallucinations about, like how the project is performing. You might end up like with an LM asking for a request for clarification, as well as maybe, like a generic status update, right? And these are all like very, very different responses to the exact same question, and it's all because of the improper kind of like context being present. Sorry, folks, I think there's something wrong with my animation, so I'm just going to get out of like the screen sharing mode and just like kind of present directly from my slides. So let's do that. Okay, and then what I wanted to kind of like show here in terms of, the evaluate of like how validation and verification can help is, okay. Uh, yeah, I'm not sure what's happening. I see it in my slides, but oh, there it is. Okay. And then what you can kind of like do here with, using this paradigm of validation and verification is you can really use like a response evaluator, right? So before you kind of like send this user query about how's the project going to an LM or wait for a response back, you can explicitly verify a response to kind of make sure it has the right context so that you're checking that source of volatility where it happens. Improper application usage. This is, one of my favorite examples of like, this world that we're in with like how complex like AI applications have become today, where, this like one of the top AI law research tools called LexisNexis talks about, they have 100% free 100% hallucination free legal citations, right? So if you ask any legal questions to their AI research tool, you'll get 100% free hallucination free responses. However, researchers at Stanford did this independent study where they kind of found that, like the rate of hallucination for LexisNexis was somewhere around 20%. And 20% is like, it's a massive rate of hallucination, right? So it's this question of like, okay, what gives? And then when I talked with the researchers, what I found was that it's because the folks at LexisNexis didn't, apply constraints in terms of what kinds of questions can be answered by their legal research tools, right? So when they did all of their application development, they assumed a certain type of questions that people would be asking. And in those questions, they had very, very low hallucinations. But because they didn't add constraints about what types of questions people can ask. Like when these independent researchers were testing it, they just asked, a lot of these different types of questions that then ended up having a lot of hallucinations. So it's just because like of how flexible LLMs tend to be that we need to explicitly add these constraints to kind of make sure that, we're not letting these systems get more volatile. And then going back to this idea of like how we can use validation and verification to like mitigate this risk. Again, in the open source, Guardrails hub, we have this like open source validator called restricted topic that, you can really use around your application and then make sure that your application is only being used to answer questions about the topic that you deem kind of like necessary. And this all happens, like in like live in real time, etc. Awesome. The fourth kind of like source of unreliability that I'm really going to talk about here is like coverage over edge cases. And this is kind of like a very fascinating issue because like what you'll typically end up seeing is that like if you do a lot of static testing, you'll typically, get these like kind of like in the head distribution of like, the queries that you'll kind of really cover. Whereas when you really ship an AI application into production, you'll end up getting, a vast variety of like edge cases. This volatility again comes from, like how unrestricted AI applications tend to be in terms of, what they can really answer. But like making sure that you're, checking the behavior over edge cases to make sure that you don't have, like unexpected ways that these edge cases behave tend to be, like a pretty common source of unreliability. And then what I'm going to like suggest here, again, going back to this top, idea of like validation and verification to match, unreliable behaviors, like making sure that any questions that, your AI application is responding to is similar to known distributions that you've seen before. So I've included this example again from our open source, Guardrails repository that you can really use to add to your application. And this will kind of make sure that you get alerts in real time if you have, like our distribution or edge case behavior that your application is looking at. And then the final one that I'm going to talk about here is model jitter. So, before we start looking at like what's happening in this little snippet here, a little setup, which is, what we're really looking at is this task of topic detection that I'm doing with OpenAI. So I'm using OpenAI to kind of like detect what topics are in a given statement. The topic options available to my OpenAI model are food, business, or politics. And the sentence that I'm asking OpenAI to detect these, questions on is Chick-fil-A is closed on Sundays. And then the really interesting thing here, you should really try it out today, and you'd be surprised by like even with setting a seed on these LM calls, like how volatile and variable the responses tend to be. So if you ask the exact same question on the exact same sentence with a seed set 10 times, you'll see like, these different topics across iterations, like business, food, business, etc. And it kind of varies based on each iteration. So there's obviously a very small contrived example, but it really shows you how volatile, like this AI, the modern Gen AI application stack kind of like typically tends to be. So I actually don't have like a validator suggestion here, but I think it kind of shows that even when you're kind of like in the post deployment stage, making sure that you're doing constant post deployment monitoring to kind of measure when this volatility happens, even with, like we'll fix all of the other issues about like improper context or like insufficient model capabilities, etc. But just because of like the inherent volatility of these systems, making sure that you're constantly validating and verifying any assumptions that you're making and then measuring them and logging them is the key to kind of like managing a lot of this generative AI volatility. So in summary, AI volatility is endemic to the new AI first software development paradigm. It occurs throughout the life cycle of AI application development, and then measuring and monitoring the volatility with these validators that we talked about over this talk is kind of like the key to managing this new source of volatility. Um, that's all my time, folks. Michael, I hope there's some time for questions, but if not, yeah.
I think we can squeeze one in. Well, thank you, Shreya. We're all trying to manage volatility in our lives and in our models. There
You're
was
right.
one
Yeah.
question in chat. And by the way, everyone should check out Guardrails. They have an open source project and an enterprise platform. Very
Mm.
popular on GitHub. I see all the stars. But so a quick question for you, Shreya, before we wrap the session. Do you have evaluators for hallucination and factuality in real time?
Yeah, that's right. We do. I think we actually have about like 6 or 7 factuality and hallucination validators that are all open source. So they're free to use, on Guardrails Hub. And they all kind of like trade off, the latency versus the accuracy of how accurately you can kind of like detect hallucinations. But if you want to check it out, I think it should be linked in like this like URL here or this QR code here if you want to scan it. But you'd be able to kind of like find those like real time hallucination detectors on open source Guardrails Hub.
Got Maybe one more question. How would you compare guardrails to like Nemo guardrails as an example? Someone was asking about Dex.
Oh yeah, that's a great question. So I think like we actually were friends with the Nemo Guardrails folks. I think we actually have like a partnership kind of like coming out pretty soon. What I would say is that like we tend to be like really community driven. So open source guardrails hub, it has about like 65 guardrails and counting today. So it's the largest collection of any guardrails, open source or otherwise, anywhere that you can find. And it's a very active community. So if there's like, research developments, we typically tend to like get those contributions pretty soon. We also tend to have a lot of like, infrastructure, kind of like utilities that are pretty useful when you're building these applications. So we'll do like streaming validation, for example, which is, typically very necessary. We have a lot of like logging and monitoring capabilities kind of built in out of the box, etc.
Awesome. Well, we're a bit over time, and we could talk a long time about all these topics. But Trey, I want to thank you very much for walking us through all this deep research and talking about some of the technology you're building.